In the sprawling tech hub of Silicon Valley, California, when software mogul Marcus Wellington's prized 2019 Lamborghini Huracán died mysteriously in his private garage, he shocked the automotive world by announcing an impossible wager of $50,000 in cold hard cash to anyone who could bring his supercar back to life. Master mechanics, exotic car specialists, and engineering teams with million-dollar diagnostic equipment all failed where precision mattered most, but sometimes the most extraordinary breakthroughs come from the most innocent minds, and what 8-year-old Sofia Chen would discover while playing with her toy tools in her father's struggling repair shop would not only resurrect a machine worth more than most people's homes, but prove that genius has no age limit, and that the purest solutions often hide in the simplest observations. The morning sun cast long shadows across the polished concrete floors of Wellington Tech's executive parking garage as Marcus Wellington stood motionless beside his disabled Lamborghini, the sleek yellow supercar that had been his pride and joy for 3 years now sat silent and lifeless despite housing a naturally aspirated V10 engine capable of producing 630 horsepower. At 42, Marcus had built his software empire from a college dorm room, transforming a simple app idea into a company worth $4.2 billion. But all his technological expertise meant nothing when faced with a car that refused to respond to any attempt at resurrection. "Still nothing, boss," called James Morrison, his personal mechanic who had been working on the Lamborghini for the past week. James was a master technician with 25 years of experience, servicing exotic vehicles from Ferraris to McLarens to Bugattis, but this particular problem had him completely stumped. The car's electrical system showed normal readings. The fuel system was pristine. The engine compression was perfect, yet somehow the vehicle remained as lifeless as an expensive piece of yellow sculpture. Marcus ran his hand along the car's carbon fiber hood, remembering the day 3 years ago when his late wife, Sarah, had surprised him with this exact vehicle for his 39th birthday. Sarah had died in a car accident 18 months later, and this Lamborghini had become more than just transportation. It was his last tangible connection to her memory and the dreams they had shared about taking cross-country road trips once his business reached a sustainable level of success. The garage housed 12 other vehicles, including a Tesla Model S Plaid, a vintage 1967 Shelby Cobra, and a McLaren 720S, but none of them held the emotional significance of the silent Huracán that now mocked him with its stubborn refusal to function. Marcus had already spent over $30,000 on diagnostic tests, replacement parts, and consultation fees from the most respected automotive experts on the West Coast. Yet the car remained as dead as the day the problem first appeared. "I want you to call Rodriguez Exotic Motors in Los Angeles," Marcus told James, his voice carrying the frustration of someone accustomed to solving problems through determination and resources. "They specialize in European supercars and have access to factory-level diagnostic equipment that we haven't tried yet." James nodded, though his expression suggested little optimism about this latest attempt. "I'll make the call, but honestly, Mr. Wellington, we've already tried everything logical. The car should be running perfectly based on every test we've performed." 25 miles away in the working-class neighborhood of East San Jose, 8-year-old Sofia Chen was helping her father Luis organize tools in their small independent automotive repair shop. Chen's Auto Repair occupied a modest building that had seen better decades, with oil-stained concrete floors, mismatched equipment purchased secondhand, and a clientele consisting mainly of neighbors who needed affordable maintenance on aging vehicles that luxury dealerships wouldn't touch. Luis Chen had immigrated from Mexico 15 years earlier with dreams of building a successful automotive business, but the reality of competing against established dealerships and chain repair shops had proven more challenging than anticipated. Despite his exceptional mechanical skills and honest business practices, Chen's Auto Repair struggled financially, operating month to month while Luis worked 16-hour days to keep the business afloat and provide for his daughter. "Papa, why Do the rich people's cars cost so much money? Sofia asked while carefully arranging wrenches by size in her father's toolbox, her small hands moving with the precision that came from years of helping in the shop after school and on weekends. Louis smiled at his daughter's question, recognizing the curiosity that had been evident since she first started walking, and immediately gravitated toward anything mechanical. Expensive cars have more complicated parts, Mia, and they're built with materials that cost much more than regular cars. But underneath all that fancy technology, they still work the same basic way as any other car. Sofia nodded thoughtfully as she continued organizing tools, her young mind already demonstrating an intuitive understanding of mechanical principles that sometimes surprised adults who witnessed her interactions with automotive systems. She had been practically raised in the repair shop since her mother's death when Sofia was 4 years old, and Louis had discovered that his daughter possessed an unusual gift for diagnosing problems that others missed. Sometimes the simplest explanation is the right one. Louise had taught her repeatedly, when something complicated stops working, look for the simple thing that everyone else overlooked because they were too focused on the complicated parts. This philosophy had served Louise well throughout his career, but he had no idea how prophetic those words would prove to be in the coming weeks as his daughter's innocent observations would challenge assumptions held by some of the most respected automotive minds in California. The afternoon brought news of Rodriguez Exotic Motors' arrival at Wellington. Tech as a team of 3 specialists unloaded sophisticated diagnostic equipment from their custom transport trailer. Led by Elena Rodriguez, a certified Lamborghini master technician with credentials directly from the factory in Italy, the team represented the highest level of expertise available for servicing the Huracán model. "Mr. Wellington," Elena said, extending her hand as she surveyed the problematic supercar, "I've worked on over 300 Huracans during my career, and I can tell you that this model has very few failure points that would cause complete electrical shutdown without obvious symptoms." Marcus felt a flicker of hope as he watched Elena's team connect their factory-level diagnostic computers to the Lamborghini's onboard systems. Their equipment cost more than most people earned in 5 years and could access diagnostic codes that standard mechanics never saw. "The initial readings are indeed puzzling," Elena admitted after 2 hours of comprehensive testing. "Every system appears to be functioning within normal parameters, yet the car refuses to start. We're seeing something that shouldn't be possible according to Lamborghini's engineering specifications." This confirmation of the problem's mysterious nature only deepened Marcus's frustration as he realized that even factory-trained specialists were encountering the same inexplicable situation that had stumped everyone else. The car's computer systems showed no error codes. The engine's mechanical components were in perfect condition, and every electrical circuit tested normally, yet somehow the vehicle remained completely unresponsive. "There is one more diagnostic procedure we can attempt," Elena said thoughtfully. "It requires special authorization from Lamborghini's technical headquarters in Italy, but they can remotely access your car's systems and perform tests that aren't available through standard diagnostic equipment." Marcus immediately approved this expensive and time-consuming process despite knowing that it would likely yield the same frustrating results that every other attempt had produced. The remote diagnostic session was scheduled for the following week, requiring coordination between multiple time zones and the temporary installation of specialized communication equipment in Marcus's garage. As Elena's team departed with promises to return for the advanced diagnostic session, Marcus found himself alone with his silent Lamborghini once again. The garage's fluorescent lights reflected off the car's polished yellow paint, creating an almost mocking gleam that seemed to highlight the machine's stubborn refusal to function. That evening, Marcus sat in his study surrounded by the technological innovations that had made him wealthy: smart home systems, artificial intelligence applications, and cutting-edge software solutions that managed everything from his business operations to his daily schedule. The irony wasn't lost on him that while he could create digital solutions for incredibly complex problems, he was powerless against one Italian supercar that had simply decided to stop working. His phone buzzed with a text message from his business partner David Kim asking about the car's status and whether the latest repair attempt had been successful. Marcus stared at the message for several minutes before typing back a simple response that he would update David once the Italian factory technicians had completed their remote analysis. Outside his floor-to-ceiling windows, the lights of Silicon Valley stretched endlessly in all directions, representing billions of dollars in technological innovation and human ingenuity. Yet none of that collective brilliance had been able to solve his seemingly simple automotive problem. The contrast between his professional success and this personal failure created a frustration that went beyond mere inconvenience, touching something deeper about his identity and capabilities. Meanwhile, at Chun's auto repair, Louise was closing up shop for the evening while Sofia finished her homework at the small desk he had set up for her in the office corner. The day had brought 3 routine maintenance jobs and 1 challenging transmission repair that had required most of Luce's attention. But the steady work wasn't enough to overcome the mounting pressure of overdue bills and increasing competition from larger repair chains. "Papa, are we going to be okay?" Sofia asked, looking up from her math homework with the serious expression that sometimes made her seem older than her 8 years. Lise knelt beside his daughter's chair, considering how to answer honestly without causing unnecessary worry. "We're going to be fine, Mia, but we need to work hard and maybe get a little bit lucky to make things better." Sofia nodded, accepting this explanation while her mind was already thinking about ways she might be able to help her father's business through her own observations and mechanical insights. She had no way of knowing that within days her innocent curiosity would intersect with a problem that had frustrated some of the most expensive automotive expertise in the world, creating an opportunity that would change both their lives forever. News of Marcus Wellington's automotive predicament spread through Silicon Valley's tight-knit community of tech entrepreneurs like wildfire, fueled by social media posts and casual conversations at exclusive networking events. What began as private frustration shared among friends quickly evolved into something much larger when Marcus made a decision that would shock the automotive world and capture international attention. Standing in his office overlooking the sprawling Wellington Tech campus, Marcus stared at the framed photograph on his desk, showing Sarah laughing beside their Lamborghini on the day she had surprised him with the car. The image captured a moment of pure joy that felt impossibly distant from his current reality of expensive failures and mounting frustration. After 3 weeks of watching the world's most qualified experts fail to resurrect his beloved supercar, Marcus had reached a breaking point that demanded dramatic action. "David, I'm going to do something that might sound crazy," Marcus told his business partner during their regular Tuesday morning strategy meeting. David Kim had been Marcus's closest friend since their Stanford days and had witnessed every major decision in the building of their software empire, but nothing had prepared him for what Marcus announced next. "I'm making a public bet, $50,000 in cash to anyone who can get that Lamborghini running again," Marcus declared in his voice, carrying the same determination that had driven him to challenge established tech giants during Wellington Tech's early years. "Every expert we've consulted has failed, and I'm tired of throwing money at specialists who can't deliver results." David's expression shifted from confusion to alarm as he processed the implications of such a public challenge. "Marcus, $50,000 is serious money, and you're talking about opening this to literally anyone who thinks they can fix a car that stumped master technicians." "Exactly," Marcus replied firmly. "Maybe the problem is that we've been limiting ourselves to conventional thinking and established expertise. What if the solution requires a completely different approach that certified mechanics wouldn't consider?" The announcement was scheduled for Thursday afternoon at a press conference in Wellington Tech's main lobby. Marcus had invited automotive journalists, technology reporters, and local media outlets to witness what he described as an unprecedented challenge to the repair industry's conventional wisdom. The marketing team had prepared materials explaining the Lamborghini's mysterious symptoms and the exhaustive attempts at diagnosis that had yielded no results. Thursday morning brought unprecedented activity to Wellington Tech's normally quiet executive parking garage as camera crews and journalists arrived to document the infamous supercar that had become the center of Silicon Valley's most talked about automotive mystery. The yellow Huracán sat in pristine condition under specially installed lighting that highlighted every curve and detail of its exotic design while revealing no obvious signs of the malfunction that had rendered it worthless as transportation. Ladies and gentlemen, Marcus began addressing the assembled crowd of reporters and onlookers. 3 weeks ago, this Lamborghini Huracán stopped running without warning or obvious cause. Since then, I've invested over $60,000 in diagnostic testing, replacement parts, and consultation fees from the most respected automotive experts in California. The crowd murmured with interest as Marcus detailed the extensive repair attempts that had included everything from complete electrical system replacement to engine teardown and rebuild, yet the car remained as unresponsive as an expensive piece of modern sculpture. Television cameras captured every word as Marcus's frustration became palpable in his voice and gestures. Factory-trained Lamborghini technicians with direct support from Italy have declared this problem impossible according to the car's engineering specifications. Marcus continued, every system tests perfectly, yet the vehicle refuses to start. I've reached the conclusion that conventional automotive expertise has failed, and it's time to try something different. The dramatic pause that followed allowed the full weight of Marcus's next words to resonate throughout the garage. I'm hereby offering $50,000 in cash to anyone who can restore this Lamborghini to running condition within the next 30 days. The money will be paid immediately upon successful demonstration that the car operates normally. The reaction was immediate and electric as reporters shouted questions about the terms and conditions, while photographers captured images of Marcus standing beside his disabled supercar. Social media posts began appearing within minutes carrying news of the unprecedented bet to automotive enthusiasts worldwide who couldn't believe that a billionaire was essentially crowdsourcing the repair of his exotic vehicle. Mr. Wellington called Jennifer Martinez from Automotive Weekly, "Are you concerned about potential damage from unqualified people attempting repairs on such an expensive vehicle?" Marcus had anticipated this question, and his response demonstrated the depth of his frustration. The car is already worthless to me in its current condition. Qualified experts have already tried everything conventional wisdom suggests, so what do I have to lose by allowing unconventional approaches? The legal parameters of the challenge were straightforward. Any individual or team could register for an attempt at repairing the Lamborghini with access granted for up to 4 hours of diagnostic and repair time. Participants would be required to sign liability waivers and work under supervision to prevent intentional damage, but otherwise they would have complete freedom to pursue whatever approach they believed might succeed. The $50,000 represents my entire emotional investment in this vehicle, Marcus explained to the crowd. If someone can restore my connection to my late wife's memory, that money will be the best investment I've ever made. Within hours of the press conference, registration requests began flooding Wellington Tech's phone lines and email systems as mechanics hobbyists, engineering students, and curious tinkerers from across the country expressed interest in attempting the seemingly impossible repair. The company's administrative staff found themselves overwhelmed by the response as potential participants ranged from retired automotive engineers to ambitious teenagers who claimed to understand something that experts had missed. The story gained national attention when major news networks picked up footage from the press conference, accompanied by expert commentary about the psychology of impossible challenges and the potential for unconventional solutions to succeed where traditional methods had failed. Automotive forums exploded with speculation about the Lamborghini's symptoms, while YouTube mechanics posted detailed videos analyzing the limited information available about the car's mysterious malfunction. This is either the most expensive publicity stunt in automotive history or a genuine breakthrough in problem-solving methodology, commented Dr. Robert Stevens, a professor of mechanical engineering at Stanford University, during a televised interview about Marcus's challenge. The first wave of registered participants included, predictably, conventional candidates, master mechanics from prestigious dealerships, automotive engineering consultants, and specialty shops that serviced exotic vehicles exclusively. Their confidence was evident in the detailed repair proposals they submitted, explaining sophisticated diagnostic procedures and advanced technologies they plan to employ in solving the mystery. Louise Chen learned about Marcus Wellington's bet while watching the evening news at his small repair shop, where he often stayed late, catching up on paperwork and maintenance tasks that couldn't be completed during regular business hours. The news anchor's description of the challenge immediately caught his attention, not because he harbored any illusions about his ability to succeed where factory specialists had failed, but because the story represented everything frustrating about the automotive industry's class divisions. $50,000. Louise murmured to himself while calculating how such an amount could transform his struggling business into something sustainable and successful. The money could update his equipment, purchase diagnostic computers that rivaled those used by luxury dealerships, and provide financial security for Sofia's education and future opportunities. But Louise was also realistic about his limitations as an independent mechanic working with aging equipment in a shop that specialized in practical repairs rather than exotic vehicle maintenance. His experience with Lamborghinis was limited to admiring them from a distance, while his actual expertise centered on the reliable domestic and import vehicles that filled his shop's service bays daily. Sofia was completing her homework at her usual desk in the shop's office corner when the news story aired, showing footage of the mysterious yellow supercar and its frustrated owner. Her attention immediately focused on the television as the reporter described the exhaustive repair attempts that had yielded no results, despite involving the most qualified technicians available. "Papa, why can't the smart mechanics fix that car?" Sofia asked, looking up from her arithmetic problems with the curiosity that drove most of her questions about the automotive world. Lee paused in his paperwork, considering how to explain the situation in terms his 8-year-old daughter could understand. Sometimes the smartest people get so focused on complicated solutions that they miss simple problems. Everyone assumes the answer must be difficult because the car is expensive and sophisticated. This explanation resonated with Sofia's own observations about problem-solving in her father's shop, where the most challenging repairs often had surprisingly straightforward solutions once the real cause was identified. She had watched Louise diagnose problems that other shops had misidentified by following systematic approaches that prioritized logical thinking over expensive technology. "Maybe they're looking in the wrong places," Sofia suggested, returning to her homework but continuing to think about the puzzle presented by a car that tested perfectly yet refused to function. The following week brought a parade of attempts as registered participants arrived at Wellington Tech's garage, armed with sophisticated equipment and detailed theories about the Lamborghini's malfunction. Each team was given 4 hours to diagnose and attempt repairs while being filmed for documentary purposes and observed by Marcus, who hoped desperately that someone would achieve the breakthrough that had eluded every previous effort. The first attempt came from Rodriguez Exotic Motors, returning with even more advanced diagnostic equipment borrowed from Lamborghini's North American headquarters, in addition to consultation support from factory engineers via video conference. Elena Rodriguez expressed confidence that the additional resources would reveal whatever subtle problem had been overlooked during previous examinations. "We're approaching this systematically," Elena explained to Marcus as her team connected laptop computers and diagnostic interfaces that represented the cutting edge of automotive technology. Factory engineers have identified 3 potential failure modes that wouldn't appear in standard testing but could cause exactly the symptoms you've described. 4 hours of intensive testing yielded the same frustrating results that had characterized every previous attempt. The car's systems appeared to function perfectly according to every available diagnostic parameter, yet somehow the vehicle remained completely unresponsive to attempts at starting. Elena's team departed with apologies and theories about intermittent failures that might require weeks of continuous monitoring to identify. The second attempt involved a team of automotive engineering students from UC Berkeley who had developed elaborate theories about software conflicts in the car's multiple computer systems. Their approach involved connecting the Lamborghini to powerful computers, capable of analyzing millions of lines of code while searching for bugs or corruption that might prevent normal operation. Modern supercars are essentially computers on wheels, explained team leader Michael Chung as his classmates surrounded the Huracán with laptops and testing equipment. We believe the problem exists in the interaction between different software systems rather than any physical malfunction. Their sophisticated analysis revealed no software anomalies or conflicts while the car's computer systems continued to report normal operation of all components, yet still refused to start when commanded. The students left convinced that the problem existed in some deeper level of the vehicle's architecture that their equipment couldn't access. Marcus watched these failures with growing despair as each unsuccessful attempt seemed to prove that his Lamborghini had developed some form of supernatural resistance to repair. The press coverage had evolved from initial excitement about the policy challenge to speculation about whether the car might be fundamentally unfixable despite its apparent perfect condition. Maybe this was a mistake, Marcus confided to David during their weekly review meeting. I'm starting to look like someone who doesn't understand that some problems can't be solved no matter how much money you throw at them. David had been supportive of the challenge initially, but was beginning to share Marcus's doubts about the wisdom of such a public demonstration of helplessness against a mechanical problem. We could quietly withdraw the offer and claim that sufficient attempts have been made. No, Marcus replied firmly. I made a commitment and I'm going to honor it even if it means admitting that my wife's last gift to me has become an expensive reminder of my own limitations. The third week of attempts brought increasingly desperate theories from participants who seemed to understand that conventional automotive expertise had been thoroughly exhausted without success. Psychic healers offered to cleanse the car's negative energy, while inventors proposed experimental technologies that existed more in imagination than practical application. Marcus endured each attempt with diminishing hope while maintaining the professional courtesy that participants deserved for their efforts. The original enthusiasm that had driven his decision to make the public bet was gradually being replaced by resignation to the possibility that his Lamborghini would remain a beautiful but useless monument to the limits of human knowledge and technology. Unknown to Marcus, however, a different kind of solution was beginning to take shape in the innocent observations of an 8-year-old girl whose mechanical intuition was about to challenge every assumption that experts had made about his impossible automotive mystery. The automotive community's response to Marcus Wellington's $50,000 challenge had attracted attention from every corner of the professional repair industry as master technicians and specialty shops saw the opportunity to demonstrate their expertise on a problem that had stumped even factory-trained specialists. The prospect of solving an impossible puzzle while earning substantial payment drew participants from across the United States, each convinced that their particular combination of experience and technology would succeed where others had failed. Advanced Automotive Solutions arrived from Phoenix, Arizona, with a reputation built on servicing the exotic car collections of professional athletes and entertainment industry celebrities. Their mobile diagnostic unit resembled a space-age laboratory equipped with oscilloscopes, thermal imaging cameras, and computer systems, capable of monitoring electrical signals at the microsecond level while analyzing patterns that human technicians might miss. "We've solved problems that other shops declared impossible," declared Robert Chen, the company's lead diagnostic specialist, as his team unloaded equipment worth more than most people's homes. "Our approach combines traditional mechanical knowledge with cutting-edge technology that can detect anomalies invisible to conventional testing methods." Marcus watched hopefully as advanced automotive solutions surrounded his Lamborghini with sensors and monitoring devices that transformed the garage into something resembling a medical operating room. Their systematic approach began with comprehensive baseline measurements of every electrical system, followed by stress testing designed to reveal intermittent failures that might occur only under specific conditions. "The key is understanding that modern supercars operate through complex interactions between dozens of computer modules," Robert explained while his technicians connected fiber optic probes to circuits deep within the Lamborghini's electrical system. "A failure in one module can cascade through the entire network, creating symptoms that appear unrelated to the actual problem source." Their investigation proceeded methodically through 4 hours of intensive testing that included simulation of various driving conditions, thermal cycling to identify temperature-sensitive components, and analysis of electromagnetic interference patterns that might disrupt normal communication between the car's multiple computer systems. Advanced diagnostic software processed terabytes of data, searching for subtle patterns that might explain the mysterious malfunction. "This is unprecedented," Robert admitted as their testing session approached its conclusion. "Every measurement indicates perfect operation, yet we're seeing behavior that contradicts the laws of electrical engineering the car should be running normally based on everything our equipment has detected." The failure of advanced automotive solutions to identify any problems reinforced the growing consensus among automotive professionals that Marcus's Lamborghini had developed some form of unique malfunction that existed outside the boundaries of conventional mechanical knowledge. Their departure left Marcus feeling more frustrated than before, as even the industry's most sophisticated diagnostic capabilities had proven inadequate. European Specialists International flew in from Miami, Florida, bringing expertise specifically focused on Italian exotic vehicles and direct relationships with Lamborghini's technical support network. Their team included Giovanni Rossi, a former factory engineer who had worked on the Huracán's original development and possessed insider knowledge about potential design weaknesses that might not be documented in standard service manuals. "I helped develop the diagnostic protocols for this exact model," Giovanni explained confidently while examining the Lamborghini's engine bay with the practiced eye of someone who understood every component's intended function. "There are certain failure modes that only someone with factory experience would recognize because they involve subtle interactions between systems that appear unrelated." Giovanni's approach emphasized understanding the vehicle's design philosophy rather than relying purely on diagnostic equipment. His team spent considerable time analyzing the relationship between mechanical components and electronic controls, while searching for problems that might not trigger standard error codes or warning systems. "Italian engineers think differently about automotive integration," Giovanni noted while testing communication pathways between the engine management system and transmission controls. "They prioritize performance over simplicity, which sometimes creates vulnerabilities that don't exist in more conventional vehicles." Their investigation included procedures that Giovanni had personally developed during his years at Lamborghini's factory, including specialized tests for electromagnetic compatibility and thermal stress analysis that could reveal problems invisible to standard diagnostic approaches. Computer modules were tested individually and in various combinations while Giovanni searched for the subtle system interactions that might explain the car's mysterious behavior. "The architecture is functioning exactly as designed," Giovanni concluded after exhaustive testing that had consumed their entire 4-hour allocation. Every module responds correctly to commands and all communication protocols operate within specifications, yet somehow the integration fails at a level that our testing cannot detect. Giovanni's failure carried particular weight among automotive professionals because his insider knowledge represented the deepest possible understanding of the Huracán's engineering philosophy, yet even this expertise had proven insufficient to identify the mysterious malfunction that prevented the car from operating normally. West Coast Performance arrived from Los Angeles with a different approach, emphasizing mechanical rather than electronic solutions to automotive problems. Their philosophy held that computerized diagnostic equipment sometimes missed fundamental issues that experienced technicians could identify through sensory observation and hands-on examination of physical components. Electronics are just fancy switches that control mechanical processes, explained Maria Santos, the shop's owner and lead technician whose 40 years of experience had taught her to trust her instincts over computer readouts when sophisticated diagnostic equipment fails. To find problems, we go back to basics and examine what those switches are supposed to be controlling. Maria's team began their investigation by physically examining every mechanical component they could access without disassembling the engine, starting with fuel system components that might prevent proper operation, despite showing normal pressure and flow readings on electronic gauges. Fuel injectors can develop problems that don't appear in standard testing, Maria noted, while using specialized equipment to measure injection patterns, and Maria noted while using specialized equipment to measure injection patterns and spray characteristics. Microscopic contamination or wear can affect performance in ways that electronic systems might not detect. Their mechanical approach included compression testing that went beyond standard measurements to analyze subtle variations in cylinder performance, vacuum testing that could reveal intake system problems invisible to electronic diagnostics, and ignition system analysis that examined spark characteristics rather than simply confirming that electrical signals were present. The mechanical foundation is solid, Maria concluded after systematic examination of every physical system she could access. Compression is perfect, ignition timing is accurate, and fuel delivery meets all specifications. The problem definitely exists in the electronic control systems that we can't fully diagnose with mechanical testing methods. Maria's conclusion reinforced the consensus that Marcus's Lamborghini suffered from some form of electronic malfunction that existed beyond the reach of both sophisticated, computerized diagnostics and traditional mechanical troubleshooting approaches, creating a mystery that seemed to transcend normal automotive knowledge. Silicon Valley Performance brought local expertise and relationships with technology companies that might offer innovative approaches to automotive diagnostics. Their owner, Jake Morrison, had built his reputation by applying cutting-edge technology solutions to classic automotive problems, often achieving breakthroughs that traditional shops couldn't match. "We're going to approach this like debugging software," Jake explained while connecting custom-built interfaces between the Lamborghini's computer systems and powerful laptops. Running specialized analysis programs, modern cars are essentially rolling computers, and we're going to treat this malfunction like a software bug that needs systematic identification and correction. Jake's team had developed proprietary diagnostic software that could monitor automotive computer networks in real time while searching for timing issues, communication errors, and data corruption problems that standard equipment might miss. Their approach emphasized understanding the digital conversations between different systems rather than simply testing individual components. Every action in a modern car involves multiple computer modules talking to each other, Jake noted while his software captured thousands of data packets flowing through the Lamborghini's internal networks. If there's a communication problem or timing issue that prevents proper coordination between systems, the car might fail to start. even though every individual component tests perfectly. Their investigation involved creating detailed maps of the electronic communication patterns within the car's computer network, while searching for anomalies that might indicate where the system integration was failing. Their software could detect timing variations measured in milliseconds that might explain why the coordination between systems wasn't occurring properly. The digital communication is flawless, Jake admitted after 4 hours of intensive network analysis. Every module responds correctly to commands. Timing is perfect, and data integrity checks pass completely. We're seeing textbook examples of how these systems should operate, yet somehow the integration still fails. Jake's failure was particularly significant because his technology-focused approach represented the cutting edge of automotive diagnostics, combining traditional mechanical knowledge with software engineering techniques that should have been capable of identifying any problems existing in the electronic domain. Elite Engine Diagnostics arrived from Las Vegas, Nevada, with specialized equipment designed specifically for high-performance engines and exotic vehicle applications. Their reputation was built on solving problems that stumped other shops, particularly issues involving the complex engine management systems found in supercars and racing vehicles. High-performance engines operate at the edge of what's mechanically possible, explained Dr. Sarah Kim, their lead engineer, who held advanced degrees in mechanical engineering and had previously worked for Formula One racing teams. Diagnostic approaches that work for conventional vehicles often miss subtle problems that only appear under the extreme conditions that these engines are designed to handle. Dr. Kim's team brought diagnostic equipment that could monitor engine parameters at racing-level precision, including sensors that measured combustion characteristics cylinder by cylinder, analysis of performance variations, and real-time monitoring of systems that operated too quickly for standard diagnostic equipment to capture accurately. We're going to test this engine under conditions that simulate actual high-performance operation, Dr. Kim explained, while installing temporary sensors that would monitor internal engine conditions. Sometimes problems only appear when systems are stressed beyond normal operating parameters. Their investigation included dynamometer testing that loaded the engine while monitoring performance characteristics, thermal analysis that could reveal problems related to heat management, and vibration analysis that might detect mechanical issues. Invisible to standard testing methods, their equipment could identify problems that existed only during specific operating conditions. Engine performance is absolutely perfect under all test conditions, Dr. Kim concluded after comprehensive analysis that had pushed the Lamborghini systems through every possible operational scenario. Power output meets factory specifications. Thermal management is flawless, and mechanical tolerances are within optimal ranges. The problem definitely doesn't exist in the engine or its direct control systems. The systematic failure of every professional diagnostic approach was beginning to create speculation within the automotive community that Marcus's Lamborghini might have developed some form of truly unique malfunction that existed outside the boundaries of conventional automotive engineering knowledge, creating a mystery that challenged fundamental assumptions about how modern vehicles operated. Independent mechanics from across California had registered for attempts at solving the puzzle, drawn by the combination of substantial financial reward and the prestige that would come from succeeding where factory specialists had failed. Their approaches ranged from methodical systematic diagnosis to intuitive troubleshooting based on decades of practical experience. Sometimes the solution is something so simple that experts overlook it because they're focused on complicated explanations, suggested Tom Bradley, a veteran mechanic from Stockton, whose 40-year career had taught him that unusual problems often had surprisingly straightforward causes. I've seen cars that wouldn't start because of loose connections that tested fine with standard equipment. Tom's approach emphasized basic electrical connections and ground points that might cause intermittent problems invisible to sophisticated diagnostic equipment. His investigation focused on fundamental electrical pathways rather than the complex computer systems that had consumed other technicians' attention. Every connection I can access tests perfectly, Tom reported after methodical examination of electrical fundamentals. Ground connections are solid, power distribution is normal, and all basic. Electrical pathways function exactly as designed. The problem exists somewhere beyond basic electrical systems. The mounting evidence that conventional automotive expertise was insufficient to solve Marcus's puzzle had begun attracting attention from academic researchers, who saw the challenge as an opportunity to study the limits of current diagnostic technology and potentially develop new approaches to understanding complex system failures. As the third week of attempts concluded without success, Marcus found himself facing the possibility that his $50,000 challenge had succeeded only in demonstrating that some automotive problems might truly be unsolvable regardless of the expertise applied or the sophistication of diagnostic equipment employed in attempting to identify their causes. The fourth week of Marcus Wellington's automotive challenge brought increasingly desperate attempts from participants who understood that conventional wisdom had been thoroughly exhausted without producing any meaningful progress towards solving the Lamborghini's mysterious malfunction. Professional pride and the substantial financial reward drove technicians to propose increasingly exotic theories about potential causes that might explain why a car could test perfectly yet refuse to operate. Quantum diagnostics arrived from Seattle, Washington, claiming expertise in electrical phenomena that existed beyond the scope of traditional automotive testing. Their approach was based on theories about electromagnetic interference patterns that might disrupt electronic systems in ways that standard equipment couldn't detect or measure. Modern vehicles exist in an increasingly complex electromagnetic environment, explained Dr. Michael Foster, the company's chief scientist, whose background combined electrical engineering with theoretical physics. We believe certain combinations of radio frequency interference can create resonance patterns that disrupt normal electronic function without leaving detectable traces. Dr. Foster's team brought specialized equipment designed to measure electromagnetic fields across frequency ranges that automotive technicians typically ignored, including sensors that could detect RADIO frequency interference patterns that might interfere with the Lamborghini's electronic control modules without triggering standard diagnostic warnings. The key is understanding that electronic systems can be affected by interference sources that don't appear during static testing, Dr. Foster noted while positioning sensors around the garage to map electromagnetic field patterns. Cell phone towers, wireless networks, and even solar activity can create interference patterns that affect sensitive electronic systems. Their investigation involved creating detailed maps of electromagnetic field strength throughout the garage while testing the Lamborghini under various interference conditions, including simulation of different radio frequency environments that might reveal sensitivity to electromagnetic phenomena that wouldn't appear during normal diagnostic procedures. Electromagnetic environment is completely normal, Dr. Foster concluded after 4 hours of sophisticated testing that had analyzed frequency patterns across ranges from extremely low frequency to microwave spectrum. There's no evidence of interference that would affect normal electronic operation, and the car's shielding appears adequate for typical electromagnetic environments. The failure of quantum diagnostics to identify any electromagnetic causes reinforced the growing consensus that Marcus's Lamborghini had developed some form of malfunction that transcended normal understanding of automotive electrical systems, creating a mystery that seemed to exist outside established engineering principles. Advanced materials analysis arrived from Denver, Colorado, with expertise in metallurgy and material science that might reveal structural problems invisible to conventional automotive diagnostics. Their approach focused on the possibility that Exotic materials used in supercar construction might develop unique failure modes not encountered in conventional vehicles. Italian supercars use advanced materials that don't exist in typical automotive applications, explained Dr. Jennifer Walsh, a materials scientist whose research focused on the behavior of carbon fiber composites and exotic metal alloys under stress conditions. These materials can develop problems that wouldn't appear in standard testing, but might affect electronic systems in unexpected ways. Dr. Walsh's team brought equipment capable of analyzing material properties at the molecular level, including ultrasonic testing that could detect internal structural changes in carbon fiber components and X-ray analysis that might reveal stress concentrations or manufacturing defects invisible to visual inspection. Carbon fiber components can develop internal delamination that affects electrical conductivity. Dr. Walsh noted while examining the Lamborghini's extensive use of carbon fiber in both structural and cosmetic applications. These changes might not affect mechanical strength, but could disrupt electrical pathways or create grounding problems. Their investigation included comprehensive analysis of every accessible carbon fiber component, using non-destructive testing methods that could detect internal structural changes, while examining metal components for stress corrosion or fatigue that might develop in exotic alloys used for high-performance applications. All materials are in excellent condition, with no evidence of degradation or structural problems. Dr. Walsh concluded after systematic examination of the Lamborghini's advanced material construction. Carbon fiber components show no delamination. Metal alloys exhibit no stress concentrations, and all materials maintain their design properties. The materials analysis failure added another layer to the growing mystery, as even the most exotic explanations for the car's malfunction were being systematically eliminated by sophisticated testing that should have revealed any problems existing in the physical domain. Cybersecurity solutions approach the problem from an entirely different perspective, proposing that the Lamborghini might have been compromised by malicious software or hacking attempts that could disable the vehicle without leaving obvious traces in standard diagnostic procedures. Modern connected vehicles are vulnerable to cyber attacks that can affect operation in ways that traditional mechanics wouldn't recognize, explained Alex Rodriguez, a cybersecurity specialist whose experience included investigating automotive hacking incidents for federal law enforcement agencies. Sophisticated attacks can modify vehicle software without triggering standard security systems. Alex's team brought computer forensics equipment designed to analyze automotive software for unauthorized modifications, including tools that could detect subtle changes in control module programming that might escape detection during normal diagnostic procedures. We're going to examine every line of code in this car's computer systems, Alex explained while connecting specialized interfaces that could extract and analyze software from the Lamborghini's multiple control modules. If someone has tampered with the programming, we'll find evidence of unauthorized modifications. Their investigation involved creating complete backup copies of all software systems within the car, followed by detailed comparison with factory original code to identify any modifications that might explain the mysterious malfunction. Comprehensive analysis of network security systems and examination of data logs that might reveal evidence of unauthorized access attempts. All software is factory original, with no evidence of modification or unauthorized access, Alex concluded after exhaustive forensic analysis that had examined millions of lines of code. Security systems are functioning normally. There's no evidence of cyber attacks, and all programming matches factory specifications exactly. The cybersecurity investigation's failure eliminated another potential explanation for the Lamborghini's mysterious behavior, while adding to the growing evidence that conventional approaches to automotive problem solving were insufficient to address whatever unique malfunction had developed. Thermodynamics engineering arrived from Austin, Texas with theories about heat-related problems that might affect electronic systems in ways that wouldn't appear during standard diagnostic testing. Their approach focused on thermal management, issues that could cause intermittent failures in sophisticated electronic control systems. High-performance vehicles generate thermal conditions that can affect electronic systems in subtle ways, explained Dr. Robert Chen, a thermal engineer whose research focused on heat transfer in electronic systems. We believe temperature-related problems might cause failures that don't appear during static testing but prevent normal operation. Dr. Chen's team brought infrared imaging equipment that could detect thermal patterns throughout the vehicle's electronic systems while monitoring temperature variations that might reveal hot spots or thermal management problems invisible to conventional diagnostic approaches. Electronic components can develop thermal sensitivities that cause failures only under specific temperature conditions, Dr. Chen noted while using thermal imaging to examine the Lamborghini's extensive electronic systems. These problems might not appear during diagnostic testing, but could prevent normal operation. Their investigation included comprehensive thermal mapping of all electronic systems under various operating conditions, including simulation of different ambient temperatures and analysis of thermal management systems that might fail to maintain proper operating temperatures for sensitive electronic components. Thermal management is functioning perfectly with all systems operating within design temperature ranges, Dr. Chen concluded after detailed thermal analysis that had monitored temperature patterns throughout the vehicle's electronic architecture. There's no evidence of thermal problems that would affect normal operation. The thermal analysis failure continued the pattern of sophisticated diagnostic approaches, finding no detectable problems despite the car's obvious malfunction, creating an increasingly inexplicable situation that challenged fundamental assumptions about automotive troubleshooting. Precision measurement systems arrived from Portland, Oregon, with equipment designed to detect mechanical problems that might exist at tolerances beyond the capability of standard automotive diagnostic tools. Their approach focused on precision measurement that could identify problems measured in microns rather than the millimeters that conventional tools could detect. Supercar engines operate at tolerances that require precision measurement beyond typical automotive standards, explained Maria Santos, a precision measurement specialist whose background included aerospace and racing applications. Problems that wouldn't affect normal engines might prevent proper operation in high-performance applications. Maria's team brought coordinate measuring machines and laser interferometry equipment that could detect mechanical variations, measured in fractions of microns, while analyzing component tolerances that might affect operation despite appearing normal to conventional measurement techniques. We're going to measure every critical dimension to aerospace standards, Maria explained while setting up precision measurement equipment that could detect tolerances variations invisible to standard automotive tools. If there are mechanical problems at the micron level, we'll find them. Their investigation included comprehensive dimensional analysis of engine components, transmission elements, and mechanical interfaces that might affect operation while using precision measurement techniques, typically reserved for aerospace and military applications. All mechanical dimensions are within factory specifications at precision levels. Maria concluded after exhaustive measurement that had analyzed component tolerances to unprecedented accuracy. There are no mechanical problems that would affect operation, even at the most demanding precision standards. The precision measurement investigation's failure to identify any mechanical causes added to the mounting evidence that Marcus's Lamborghini had developed some form of truly unique malfunction that existed outside the boundaries of conventional automotive engineering knowledge. Fluid Analysis Laboratory arrived from Phoenix, Arizona, proposing that contamination in various automotive fluids might cause problems that wouldn't appear in standard testing but could prevent normal operation. Their approach focused on molecular level analysis of every fluid system within the vehicle. Exotic vehicles use specialized fluids that can develop contamination problems. not encountered in conventional automotive applications, explained Dr. Sarah Kim, a chemical engineer whose expertise included analysis of high-performance lubricants and hydraulic fluids. Microscopic contamination might affect system operation without triggering standard warning systems. Dr. Kim's team brought laboratory-grade, analytical equipment that could detect contamination at the molecular level, including spectrographic analysis that could identify foreign substances in concentrations measured in parts per billion, while examining fluid degradation that might not appear in conventional testing. We're going to analyze every fluid in this vehicle to laboratory standards, Dr. Kim explained while collecting samples of engine oil, transmission fluid, brake fluid, and hydraulic fluids for comprehensive chemical analysis. If there's contamination that's causing problems, we'll identify it. Their investigation included complete chemical analysis of all automotive fluids using techniques typically reserved for research laboratories, while examining contamination that might affect operation, despite being invisible to standard automotive fluid testing procedures. All fluids are within specifications with no contamination detected at any level, Dr. Kim concluded after comprehensive chemical analysis that had examined molecular composition of every fluid system. There's no evidence of contamination or fluid degradation that would affect normal operation. The fluid analysis failure eliminated another potential explanation while continuing the pattern of sophisticated diagnostic approaches finding perfect conditions despite the car's obvious malfunction, creating a mystery that seemed to transcend normal automotive engineering principles. As the fourth week of attempts concluded without any progress toward identifying the Lamborghini's mysterious malfunction, Marcus found himself confronting the possibility that his $50,000 challenge had succeeded only in demonstrating the limits of current automotive diagnostic technology while revealing that some problems might truly exist beyond the reach of conventional expertise, regardless of the sophistication of equipment or techniques employed in attempting to solve them. The systematic failure of every professional approach had begun generating academic interest in the challenge as researchers recognized that Marcus's Lamborghini represented a unique case study in the limits of current diagnostic methodology, while potentially offering insights into new approaches for understanding complex system failures that transcended traditional automotive troubleshooting paradigms. The fifth week of Marcus Wellington's challenge witnessed a dramatic shift in the types of participants attempting to solve his Lamborghini mystery as word spread through social media and online forums that professional automotive expertise had been thoroughly exhausted without producing any meaningful results. The systematic failure of factory-trained technicians, advanced diagnostic equipment, and specialized engineering approaches had created an opportunity for unconventional thinkers to propose alternative solutions that existed outside traditional automotive knowledge. Amateur mechanics and weekend enthusiasts began registering for attempts, driven by the belief that fresh perspectives unencumbered by formal training might identify problems that experts had overlooked due to their reliance on conventional diagnostic approaches. These participants brought enthusiasm, creativity, and willingness to consider possibilities that professional technicians might dismiss as impractical or theoretically impossible. Thomas Mitchell, a retired machinist from Sacramento, arrived with hand-built diagnostic tools and 40 years of experience solving mechanical problems through intuition and careful observation rather than sophisticated electronic equipment. His philosophy emphasized understanding the fundamental mechanical relationships that electronic systems were designed to control rather than focusing on the computerized interfaces that had consumed other technicians' attention. Computers are just fancy ways of controlling basic mechanical processes, Thomas explained while examining the Lamborghini, with methods that seemed primitive compared to the high-tech approaches that had preceded him. When electronic diagnostics fail, you go back to understanding what those computers are supposed to make happen mechanically. Thomas's investigation focused on mechanical relationships between components, using techniques developed during decades of maintaining industrial machinery that operated without the electronic assistance found in modern vehicles. His approach emphasized sensory observation, listening to subtle sounds, feelings for vibrations, and examining physical evidence that might reveal problems invisible to electronic diagnostic systems. "There's something wrong with the fuel delivery timing," Thomas announced after 2 hours of careful examination. "I can hear it in the way the fuel pumps cycle when the ignition is activated. The rhythm isn't quite right for proper fuel pressure development." His observation intrigued Marcus because no previous diagnostic approach had identified any problems with fuel system operation despite comprehensive testing that had included pressure measurements, flow analysis, and electronic monitoring of fuel delivery components. Thomas's claim that mechanical timing issues existed challenged the electronic diagnostic evidence that had consistently shown perfect fuel system function. Electronic diagnostics measure pressure and flow, but they don't necessarily detect timing relationships between different components, Thomas explained while using a simple stethoscope to listen to fuel system operation. If the timing between fuel pump activation and pressure regulation isn't synchronized properly, the system might not develop proper pressure despite showing normal readings on electronic gauges. Thomas's investigation revealed subtle mechanical timing variations that existed within normal electronic parameters but might affect system integration in ways that prevented proper operation. His approach emphasized understanding mechanical cause and effect relationships rather than relying on electronic measurements that might miss timing-related problems. "The fuel system timing is definitely abnormal," Thomas concluded after systematic analysis of mechanical relationships between fuel delivery components. "But I don't have the tools or expertise to correct timing problems in such a sophisticated electronic system." Thomas's partial success in identifying a potential problem that had escaped every previous diagnostic attempt demonstrated that unconventional approaches might indeed reveal issues invisible to standard automotive troubleshooting methods. His departure left Marcus feeling more hopeful than he had in weeks. Despite the mechanic's inability to complete the repair. Jennifer Walsh, a mechanical engineering student from UC Davis, arrived with theories about resonance phenomena that might affect electronic systems in ways that wouldn't appear during static testing. Her academic background provided theoretical knowledge about system interactions that practicing technicians might not consider during routine diagnostic procedures. Modern vehicles are complex dynamic systems where seemingly unrelated components can interact in unexpected ways, Jennifer explained while setting up oscilloscopes and frequency analyzers borrowed from her university's engineering laboratory. Resonance effects between mechanical and electronic systems might create interference patterns that prevent normal operation. Jennifer's investigation focused on dynamic system interactions using academic research methods rather than practical automotive diagnostic approaches. Her equipment could detect vibration patterns and resonance frequencies that might reveal mechanical-electronic interactions invisible to conventional testing methods. "I'm finding resonance patterns between the engine mounting system and electronic control modules that might create interference during certain operating conditions," Jennifer reported after hours of frequency analysis. "The vibration patterns suggest that mechanical resonance might be affecting electronic system operation." Her academic approach revealed theoretical problems that practicing technicians had missed, but her lack of practical automotive experience prevented her from determining whether these resonance effects were sufficient to cause the complete operational failure that Marcus's Lamborghini exhibited. "The resonance patterns are definitely abnormal, but I can't determine if they're severe enough to prevent the car from starting," Jennifer concluded while packing her borrowed equipment. "This would require more extensive testing with specialized equipment that I don't have access to." Jennifer's theoretical insights added another layer to the growing understanding that Marcus's Lamborghini might suffer from complex system interactions that transcended individual component failures while existing in the spaces between different diagnostic specialties. Kevin Thompson, a software developer from San Francisco, approached the problem as a systems integration challenge, proposing that modern vehicles represented complex networks where failures might occur in communication protocols rather than individual components. His background in network troubleshooting provided perspectives that automotive technicians typically wouldn't consider. Cars are basically rolling computer networks where dozens of processors need to coordinate their activities perfectly, Kevin explained while connecting network analysis equipment to the Lamborghini's internal communication systems. Network failures can prevent coordination between systems even when individual components function perfectly. Kevin's investigation emphasized communication protocols and data flow analysis using network troubleshooting techniques adapted for automotive applications. His equipment could monitor network traffic patterns and detect communication anomalies that might not trigger standard automotive diagnostic warnings. I'm seeing network timing issues that suggest communication delays between critical control modules, Kevin reported after analyzing thousands of network packets flowing through the car's internal systems. The delays are within normal parameters individually, but their cumulative effect might prevent proper system coordination. His network analysis revealed subtle communication timing variations that existed within acceptable parameters for each individual system, but might combine to create coordination problems that prevented proper vehicle operation. The discovery suggested that system integration failures could occur even when all components tested normally. The communication timing issues are definitely present, but I don't have the automotive expertise to determine if they're severe enough to prevent starting, Kevin concluded after comprehensive network analysis. This would require someone who understands both network protocols and automotive system integration. Kevin's insights into network communication problems added to the growing evidence that Marcus's Lamborghini suffered from complex system integration issues that existed in the spaces between different technical specialties, requiring interdisciplinary knowledge to understand fully. Meanwhile, 25 miles away in East San Jose, Sofia Chen was following news coverage of the ongoing challenge with the fascination that mechanical puzzles always generated in her young mind. The televised reports about failed diagnostic attempts had captured her attention, not because she understood the technical details, but because the story reminded her of problems she had observed in her father's repair shop. "Papa, why do all the smart mechanics keep saying the car works perfectly if it won't start?" Sofia asked while helping Louise organize tools in their modest shop. "That doesn't make sense. If something doesn't work, then something must be broken." Luis paused in his inventory of socket wrenches, considering how to explain the complexities of modern automotive diagnostics to his 8-year-old daughter, whose mechanical intuition often surprised him with its clarity and directness. "Sometimes, Mia, the problem isn't with the parts themselves, but with how they work together," Luis replied thoughtfully. "It's like when our old television works fine, but we can't get a picture because the cable connection is loose. The television isn't broken, but the system doesn't work." This explanation resonated with Sofia's observations about seemingly mysterious problems that had simple solutions once the real cause was identified. She had watched her father solve challenging repairs by looking for fundamental problems that other mechanics had overlooked while focusing on complicated electronic explanations. Maybe they're looking at the parts instead of looking at the parts, instead of looking at the parts, instead of looking at the parts, instead of looking at the parts. Connections, Sofia suggested with the logical thinking that characterized her approach to mechanical problems. If all the parts work, but the car doesn't start, then maybe something isn't connected right. Louis smiled at his daughter's insight, recognizing the wisdom that often emerged from her uncomplicated approach to complex problems. Sofia's suggestion about connection problems echoed his own experience with difficult Diagnoses that were eventually traced to simple issues that sophisticated diagnostic equipment had missed. You might be right, Mia. Sometimes the simplest explanation is the correct one, even when experts are looking for complicated answers. Louise agreed while wondering if Sofia's innocent observation might contain more wisdom than the expensive diagnostic approaches that had failed to solve Marcus. Wellington's automotive mystery. The evening news featured interviews with several participants who had attempted repairs during the week, including Thomas Mitchell, whose partial success in identifying fuel system timing problems had generated speculation that the solution might require combining insights from multiple diagnostic approaches rather than relying on any single methodology. We've learned that this car's problem exists in the spaces between different systems, explained automotive journalist Patricia Rodriguez. During her analysis of the week's developments, individual components test perfectly, but something prevents them from working together properly. The growing understanding that Marcus's Lamborghini suffered from system integration problems rather than component failures was beginning to attract attention from academic researchers who recognized the challenge as a case study in complex system behavior that transcended traditional automotive troubleshooting paradigms. Dr. Robert Stevens from Stanford University's Mechanical Engineering Department had been following the challenge with interest as it demonstrated the limits of current diagnostic technology while potentially offering insights into new approaches for understanding complex system failures. This case represents a perfect example of emergent system behavior, where the interaction between components creates problems that can't be detected by examining individual parts. Dr. Stevens explained during a telephone interview with Automotive Media. It suggests that we need new diagnostic paradigms that emphasize system integration rather than component testing. The academic interest in Marcus's challenge was beginning to generate research proposals for studying complex automotive systems using interdisciplinary approaches that combined mechanical engineering, network analysis, materials science, and systems theory to understand failures that transcended traditional diagnostic boundaries. Sofia continued to follow the news coverage with growing conviction that the solution to Marcus's automotive mystery lay in some simple connection problem that sophisticated diagnostic equipment was missing because experts were focused on proving that complex systems worked rather than ensuring that basic connections function properly. "Papa, what if the car has a loose wire that the computers can't see?" Sofia asked during dinner while sharing her latest theory about the Lamborghini's mysterious malfunction. If the wire is almost connected, the computers might think everything is fine, but the car still wouldn't start. Luis considered his daughter's suggestion, recognizing that loose connections were indeed among the most challenging problems to diagnose because they could cause intermittent symptoms that didn't appear during static testing while creating exactly the type of system integration failures that seemed to characterize Marcus's automotive mystery. "That's actually a very good theory, Mia," Luis replied thoughtfully. "Loose connections can fool even the best diagnostic equipment because they might work fine during testing, but fail when the car tries to start." Sofia's theory about connection problems aligned perfectly with the emerging understanding that Marcus's Lamborghini suffered from system integration issues rather than component failures, while suggesting that the solution might require someone willing to examine fundamental electrical connections rather than relying on sophisticated electronic diagnostic approaches. The conversation between father and daughter represented a turning point in their understanding of the challenge, as Sofia's innocent observations began to crystallize into a coherent theory about the type of simple fundamental problem that might cause complex system failure while remaining invisible to conventional diagnostic methodologies. As the fifth week concluded with continued failure by unconventional participants to solve the mystery, Marcus found himself confronting the possibility that his challenge had attracted every type of expertise available yet still hadn't produced the breakthrough that would restore his connection to Sarah's memory through the resurrection of her final gift to him. The following Monday morning brought an unexpected development to Marcus Wellington's automotive challenge when Louise Chen made a decision that surprised even himself as he watched his 8-year-old daughter Sofia methodically organize tools. While explaining her theories about loose connections and system integration problems, Sofia's consistent focus on fundamental electrical connections rather than sophisticated diagnostic approaches had begun to convince Luz that his daughter might possess insights that expensive equipment had missed. "Sofia, what if we went to look at that famous car?" Lee suggested during breakfast while considering the wisdom of involving his young daughter in such a high-profile situation. "You seem to have ideas about what might be wrong, and maybe we could learn something by seeing the actual problem." Sofia looked up from her cereal with excitement mixed with uncertainty about whether her father was serious about visiting the billionaire's garage, where so many qualified experts had failed to achieve success. "Papa, do you really think they would let us try to help when all those smart mechanics couldn't fix it?" "Sometimes, Mia, the smartest people get so focused on complicated solutions that they miss simple problems," Luis replied, echoing the philosophy that had guided his approach to challenging repairs throughout his career. Maybe they need someone who looks for basic problems instead of advanced technical issues. The decision to register for an attempt at Marcus Wellington's challenge represented a significant risk for Luis, whose modest repair shop couldn't afford the time away from paying customers or the potential embarrassment of failing publicly, where sophisticated diagnostic teams had been unsuccessful. However, Sofia's unwavering conviction that the solution involved fundamental connection problems had gradually convinced him that their unconventional perspective might succeed where traditional approaches had failed. Luz called Wellington Tech's administrative office that afternoon to request registration for a diagnostic attempt, explaining that he operated an independent repair shop and wanted to examine the Lamborghini with his daughter, who had developed theories about potential connection problems that might explain the mysterious malfunction. "Mr. Chen," replied Sandra Martinez, the administrative coordinator who had been handling challenge registrations, "I need to inform you that this vehicle has been examined by factory-trained specialists with equipment worth millions of dollars. Are you certain you want to attempt a repair that has stumped master technicians? My daughter has ideas about simple problems that expensive equipment might miss." Louise explained, feeling somewhat foolish for suggesting that an 8-year-old could solve automotive mysteries that had defeated engineering teams. "We understand this is a long shot, but we'd like the opportunity to examine the car." Sandra scheduled their appointment for Thursday afternoon, noting that Louise would be the first independent mechanic to bring a child assistant to the challenge, while wondering privately whether desperation was driving Marcus to accept increasingly unlikely participants in his quest to resurrect his beloved Lamborghini. Wednesday evening found Sofia and Louise preparing for their appointment by reviewing everything they knew about modern automotive electrical systems, while discussing approaches that might reveal connection problems invisible to sophisticated diagnostic equipment. Sofia's mechanical intuition was complemented by Luz's practical experience, creating a combination that might succeed where pure expertise or advanced technology had failed. "Remember, Mia, we're looking for things that test fine individually, but don't work together properly," Luz explained while gathering basic diagnostic tools that seemed primitive compared to the equipment that previous participants had employed. Loose connections, bad grounds, or corroded contacts that electronic equipment might not detect. Sofia nodded seriously, understanding that their appointment represented an opportunity to test theories that had been developing in her mind throughout weeks of following the challenge. "Papa, what if the problem is somewhere that the fancy equipment can't reach, like inside a connector that looks fine from outside?" This possibility had occurred to Luis as well, based on his experience with intermittent electrical problems that could frustrate even experienced technicians when connections appeared normal during visual inspection but failed under operational stress or environmental conditions that didn't exist during static testing procedures. Thursday afternoon arrived with surprising media attention, as news outlets had learned about the unusual participant who planned to bring his 8-year-old daughter to attempt repairs on a problem that had stumped international experts. Camera crews gathered outside Wellington Tech's gates, hoping to capture footage of what many viewed as either an inspiring story of determination or a publicity stunt that would end in predictable failure. Marcus Wellington met Lise and Sofia personally in the executive garage, his curiosity about their unconventional approach outweighing his skepticism about the likelihood that a small independent mechanic could succeed where factory specialists had failed repeatedly over the previous month. "Mr. Chen," Marcus said, extending his hand while studying Sofia with the gentle expression he reserved for children. "I understand your daughter has theories about what might be wrong with my car." Sofia stepped forward with the polite confidence that Louise had instilled in her through years of interacting with customers in their repair shop. "Mr. Wellington, Papa taught me that when something doesn't work, you look for the simplest explanation first before you try complicated ones." Marcus knelt to Sofia's eye level, recognizing sincerity and intelligence in her expression, while remembering his own childhood fascination with mechanical problems and the satisfaction that came from understanding how complex systems operated through the coordination of simple components working together properly. "What do you think might be wrong with my Lamborghini?" Marcus was genuinely interested in hearing Sofia's perspective despite the obvious absurdity of seeking automotive advice from an 8-year-old girl who had never seen a supercar except on television. "I think maybe something isn't connected." "Right," Sofia replied with the directness that characterized her approach to mechanical problems. "If all the parts work, but the car doesn't start, then maybe the parts can't talk to each other because a wire is loose or dirty." This explanation aligned with emerging theories about system integration problems that had been suggested by several previous participants, though none of them had been able to identify specific connection issues that might cause the symptoms. Marcus's Lamborghini exhibited consistently. Lise began their investigation by examining basic electrical connections using simple tools that could detect problems invisible to sophisticated diagnostic equipment. His approach emphasized fundamental electrical principles rather than complex electronic analysis, while Sofia observed carefully and asked questions about everything she saw. "We're going to start with battery connections and work our way through the main electrical pathways," Lise explained to Marcus while checking terminal connections that previous technicians had tested repeatedly. Sometimes corrosion or loose connections can fool electronic diagnostics because they work fine under light loads but fail when the system tries to draw a starting current. Their methodical examination of electrical fundamentals revealed the same perfect conditions that every previous diagnostic attempt had discovered. Battery connections were clean and tight. Main electrical pathways showed normal resistance, and continuity testing confirmed that power distribution systems functioned exactly as designed. "Papa, look at this," Sofia said quietly while examining the engine compartment with the careful attention she brought to mechanical problems in her father's shop. "This wire looks different from the others." Sofia was pointing to a portion of the main engine wiring harness where one section appeared slightly discolored compared to surrounding wires. The difference was so subtle that it would be invisible unless someone was specifically looking for visual anomalies, rather than relying on electronic testing methods. Lise examined the area Sofia had identified, discovering that several wires within the main harness showed signs of subtle heat damage that had affected the insulation without completely severing the conductors. The damage was so minor that electrical testing would show normal continuity while potentially creating resistance that could affect system operation under load conditions. "This is interesting," Lise murmured while carefully examining the damaged wiring with a magnifying glass. "The insulation has been compromised by heat, but the wires are still connected. This could create intermittent resistance that wouldn't show up in standard testing. The heat-damaged wiring was located in an area of the engine compartment, where normal service procedures wouldn't require examination, explaining why previous diagnostic attempts had missed the subtle insulation damage that Sofia's careful visual inspection had revealed through systematic observation rather than electronic testing. "Mr. Wellington," Louise said, carefully while continuing to examine the damaged wiring, "this heat damage could explain why your car tests perfectly but won't start. The wires are still connected, but they might not be carrying current properly under starting loads." Marcus watched with growing excitement as Louise traced the damaged wiring through the engine compartment, identifying the specific circuits that had been affected by heat damage that was invisible to electronic diagnostic equipment, but could prevent proper system operation during high-current starting procedures. These wires control communication between the engine management system and the starter motor control module, Louise explained, while documenting the extent of the heat damage. "If the resistance is too high, the systems can't coordinate properly, even though they test fine individually." The discovery represented exactly the type of system integration problem that previous participants had theorized about but hadn't been able to identify, specifically connection problems that existed within normal electrical parameters but prevented proper coordination between systems. During actual operation, Sofia continued her careful visual examination of the engine compartment, while Louise tested the damaged wiring with simple tools that could measure resistance under load conditions rather than the static testing that sophisticated diagnostic equipment typically performed. "Papa, the resistance is definitely too high when you test it the way the car would use it," Sofia observed while watching her father's testing procedures. "That's why the fancy equipment didn't find the problem, because it tests things differently than how they actually work." This insight demonstrated Sofia's intuitive understanding of the difference between static diagnostic testing and dynamic operational conditions, explaining why sophisticated equipment had consistently reported normal function while the car remained unable to start under actual operating conditions. Louise spent the next hour carefully repairing the heat-damaged wiring using techniques developed through years of practical electrical repair work. His approach emphasized restoring proper electrical function rather than simply meeting electronic diagnostic parameters that might not reflect actual operational requirements. "The wiring repair is complete," Louise announced after methodical restoration of proper electrical connections. "The resistance measurements now show normal values under both static and dynamic testing conditions." Marcus held his breath as Louise prepared to test the Lamborghini's starting system for the first time in over a month. The moment represented either vindication of Sofia's simple approach to complex problems, or another disappointing failure to add to the growing list of unsuccessful attempts. The engine turned over immediately when Marcus pressed the start button, settling into the smooth, powerful idle that had been absent for so long, while the garage filled with the distinctive sound of the naturally aspirated V10 engine running exactly as it had been designed to operate. "It works," Sofia said quietly with satisfaction rather than surprise. "Papa always says that simple problems have simple solutions if you look in the right places." Marcus stood speechless beside his resurrected Lamborghini as the reality of what had just occurred began to sink in. An 8-year-old girl had succeeded where international experts had failed by applying fundamental diagnostic principles rather than sophisticated technology to identify a problem that existed in the space between individual component testing and integrated system operation. The successful repair represented more than just the restoration of mechanical function. It validated Sofia's approach to problem solving, while demonstrating that wisdom and capability could emerge from unexpected sources when conventional expertise proved insufficient to address complex challenges that required fresh perspectives and willingness to examine fundamental assumptions. The sound of the Lamborghini's V10 engine purring to life after weeks of silence created a moment of profound stillness in the garage as everyone present struggled to comprehend what had just occurred. Marcus Wellington stood frozen beside his resurrected supercar, while the distinctive rumble that had been absent for so long filled the space with mechanical music that seemed almost impossible after the systematic failure of every previous repair attempt. "I can't believe it," Marcus whispered, his voice barely audible over the engine's smooth idle, as he stared at Sofia with an expression that combined amazement, gratitude, and something approaching reverence. "You actually did it, an 8-year-old girl. Solved a problem that stumped factory engineers." Sofia looked up at Marcus with the modest satisfaction that came from confirming what she had believed all along about the nature of the problem. "Mr. Wellington, Papa always teaches me that if something doesn't work, there has to be a reason, and the reason is usually simpler than people think." Luis stood beside his daughter, feeling a mixture of pride and disbelief as he watched the Lamborghini running perfectly after his simple wiring repair had restored the communication pathways that sophisticated diagnostic equipment had somehow missed despite comprehensive testing by internationally recognized experts. Sometimes the most obvious solutions are invisible to people who are looking for complicated explanations, Luis said thoughtfully while observing the engine's flawless operation. Sofia saw what others missed because she wasn't trying to prove how smart she was. She was just trying to understand what was wrong. The garage's atmosphere had transformed from the frustrated disappointment that had characterized previous failed attempts into something approaching celebration as the reality of Sofia's success began to penetrate the shock that had initially greeted the engine's resurrection. Marcus walked slowly around his Lamborghini, listening to the engine's normal operation, while trying to process the implications of what had just happened. A child from a struggling repair shop had achieved what teams of specialists with millions of dollars worth of equipment had declared impossible. "Sofia," Marcus said, kneeling beside the girl who had given him back more than just a functional vehicle, "you've done something incredible. Not just fixing my car, but showing everyone that wisdom doesn't always come from the expected places." Sofia smiled shyly while watching the Lamborghini's engine bay, where the repaired wiring now carried electrical current properly between systems that had been unable to communicate effectively for weeks. "I just looked for what was different. Papa taught me that when everything seems perfect but doesn't work, something small is usually wrong." The media crews waiting outside Wellington Tech's gates erupted into activity when word spread that the Lamborghini was running again, creating a frenzy of reporters and camera operators who demanded access to document the successful conclusion of Silicon Valley's most talked about automotive challenge. Marcus made the decision to invite a small group of journalists into the garage to witness the remarkable scene of an 8-year-old girl standing beside a running Lamborghini that she had somehow restored to life through methods that no professional technician had considered. "Ladies and gentlemen," Marcus announced to the assembled media representatives, "I want you to meet Sofia Chen, the 8-year-old girl who succeeded where every automotive expert in California failed." The journalists struggled to comprehend the story they were witnessing as Sofia explained her diagnostic approach with the clear, logical thinking that had led her to identify visual clues that sophisticated electronic equipment had missed completely. "I just looked for things that seemed different," Sofia told the reporters with the straightforward honesty that characterized her explanation of complex mechanical concepts. "When Papa taught me that loose connections can fool computers, I started looking for connections that might be loose in ways that computers couldn't see." The questions from automotive journalists revealed the profound implications of Sofia's success for the entire diagnostic industry, as her simple visual inspection had revealed problems that millions of dollars worth of testing equipment had failed to detect. "This represents a fundamental challenge to current diagnostic methodology," observed Patricia Rodriguez from Automotive Weekly. "If an 8-year-old can find problems that factory equipment misses, we need to reconsider our entire approach to complex system troubleshooting." Marcus listened to the media discussion while watching Sofia interact with reporters who were clearly amazed by her mechanical knowledge and analytical thinking. Her success had implications that extended far beyond the restoration of one exotic vehicle. Sofia's achievement demonstrates that fresh perspectives, unencumbered by conventional assumptions, can sometimes see solutions that expertise overlooks, Marcus explained to the journalists. She succeeded because she approached the problem differently, not because she knew more than the experts. The story of Sofia's success began spreading immediately through social media and news networks, creating international attention for the remarkable achievement of a child who had solved an automotive mystery that had frustrated professionals across multiple industries. Luis watched the media attention surrounding his daughter with mixed emotions, feeling proud of Sofia's accomplishment while worrying about the impact that sudden fame might have on her normal childhood development and their quiet life in East San Jose. "Mr. Chen," asked Jennifer Martinez from Silicon Valley Business Journal, "how does it feel to know that your daughter has just earned $50,000 through her mechanical intuition?" The question about the substantial financial reward. Luis back to the practical implications of Sofia's success as he realized that their modest circumstances were about to change dramatically through his daughter's remarkable achievement. "The money will help us very much," Luis replied honestly, "but I'm more proud that Sofia proved you don't need expensive equipment to solve problems if you understand basic principles and look carefully at what you're examining." Marcus had been thinking about the $50,000 payment throughout the media interviews, recognizing that while the amount represented significant money for the Chen family, it seemed inadequate compensation for restoring his connection to Sarah's memory through the resurrection of her final gift. "Luis, Sofia," Marcus said when the journalists had finished their interviews, "the $50,000 is yours as promised. But I want to discuss additional ways to recognize what Sofia has accomplished here today." The suggestion of additional compensation surprised Luis, who had never expected to succeed at the challenge, much less receive anything beyond the advertised reward for solving Marcus's automotive mystery. "Mr. Wellington, you don't owe us anything more than what you promised," Luis said with the dignity that had characterized his approach to business throughout his career. "Sofia fixed your car because she wanted to help, not because she expected extra payment." Marcus smiled at Luis's integrity while recognizing the same values that had produced Sofia's remarkable character and her intuitive approach to mechanical problem-solving. "I understand your position, but Sofia's achievement deserves recognition that goes beyond simple payment for services rendered." The conversation about additional recognition was interrupted by the arrival of Dr. Robert Stevens from Stanford University's Mechanical Engineering Department, who had driven immediately to Wellington Tech when he learned about Sofia's successful repair. "Mr. Wellington, I need to understand exactly how this repair was accomplished," Dr. Stevens said with the excitement of an academic who had discovered a potentially revolutionary case study. "If this child identified problems that factory diagnostics missed, we need to document her methodology for research purposes." Sofia listened to Dr. Stevens's request with a serious attention. She brought to adult conversations about mechanical topics, though she seemed puzzled by the professor's assumption that her diagnostic approach represented something revolutionary rather than simple common sense. "I just looked for things that were different from what they should be," Sofia explained to Dr. Stevens with patience that seemed remarkable for someone her age. "When computers say everything is perfect, but the car doesn't work, something has to be wrong that the computers can't see." Dr. Stevens took careful notes as Sofia described her visual inspection methodology, recognizing that her approach represented an intuitive application of diagnostic principles that engineering students typically learned through years of formal education. "This young lady has demonstrated diagnostic thinking that some of my graduate students struggle to master," Dr. Stevens observed while studying Sofia's explanation of how she had identified the heat-damaged wiring. Her success suggests that intuitive problem-solving might be more effective than systematic electronic analysis. The academic interest in Sofia's achievement added another dimension to the story. as researchers began to recognize that her success might offer insights into more effective approaches for diagnosing complex system failures that transcended traditional engineering methodologies. Marcus made a decision that had been forming in his mind since the moment his Lamborghini had started running again, recognizing that Sofia's achievement deserved recognition that would provide lasting benefits rather than simple one-time payment. Sophia Louise, I want to establish an educational fund that will ensure Sophia can pursue any educational opportunity she chooses, including mechanical engineering or automotive technology, if those subjects continue to interest her. Marcus announced, creating surprised silence in the garage. The offer of educational funding represented opportunities that Louise had never imagined possible for his daughter, whose natural mechanical abilities had been nurtured in their modest repair shop without access to formal engineering education or advanced technical training. Mr. Wellington, that's incredibly generous, but Sophia is only 8 years old. We don't know what she wants to study when she grows up. Luis replied, though his voice carried obvious emotion at the prospect of unlimited educational opportunities for his remarkable daughter. That's exactly why the fund should be flexible enough to support whatever direction Sophia's interests take her, Marcus explained. Whether she becomes a mechanical engineer, a research scientist, or decides to follow a completely different path, she should have every possible opportunity available. Sophia listened to the discussion about her future education with the thoughtful expression that characterized her approach to important decisions, though. At 8 years old, the concept of college and career planning remained somewhat abstract despite her obvious intellectual capabilities. Thank you, Mr. Wellington, Sophia said with sincere appreciation. I would like to learn more about how cars work and maybe help other people solve problems that seem impossible. The simplicity of Sophia's response captured perfectly the qualities that had enabled her success: humble curiosity about mechanical systems, combined with genuine desire to help others rather than seeking recognition or financial reward for her abilities. As the excitement in the garage began to settle into a more manageable atmosphere, Marcus found himself looking at his Lamborghini with emotions that went far beyond relief at having a functional vehicle again. Sophia's success had restored more than mechanical operation. It had renewed his faith in the possibility that seemingly impossible problems could be solved through determination, wisdom, and willingness to consider unconventional approaches. Sophia, Marcus said, as the Chen family prepared to leave Wellington Tech, you've given me back something I thought I had lost forever. Not just my car, but my belief that there are still people in the world who care more about helping others than advancing themselves. The profound gratitude in Marcus's voice reflected his understanding that Sophia's achievement represented values that had become increasingly rare in his experience of Silicon Valley's competitive technology industry, where success was typically measured in dollars rather than human connections. The day's events had transformed not only Marcus's automotive situation, but had created relationships that would endure long beyond the immediate excitement of solving his Lamborghini's mysterious malfunction, establishing connections between different worlds that might never have intersected without the catalyst of an impossible mechanical challenge. 6 months after Sofia Chen's remarkable diagnosis had resurrected Marcus Wellington's Lamborghini from its mysterious malfunction, the ripple effects of her achievement continued to transform lives and challenge assumptions throughout Silicon Valley's automotive and technology communities. What had begun as a desperate billionaire's public bet had evolved into something far more significant, creating opportunities for educational initiatives and new approaches to problem solving that extended well beyond the original automotive challenge. The Sofia Chen Educational Foundation had been established with an initial endowment of $5 million from Marcus Wellington's personal fortune, designed to support young people who demonstrated exceptional problem-solving abilities regardless of their economic backgrounds or formal educational credentials. The Foundation's mission emphasized identifying and nurturing intuitive thinking capabilities that traditional educational systems might overlook or undervalue. We've learned that breakthrough solutions often come from minds that haven't been trained to accept conventional limitations, explained Dr. Sarah Kim, the Foundation's director who had left her position at Stanford University to oversee programs that would identify and support young innovators across multiple disciplines. Sofia herself had become the Foundation's first scholarship recipient, receiving comprehensive educational support that included private tutoring in advanced mathematics and science, while maintaining her hands-on learning at her father's repair shop, where her mechanical intuition continued to develop through practical application of theoretical knowledge. "I still like working with Papa better than studying books," Sofia confided to Marcus during one of their regular monthly meetings at Wellington Tech. "But the math classes help me understand why things work the way they do, instead of just knowing that they work." Marcus had insisted on maintaining personal involvement in Sofia's educational development, recognizing that her unique combination of intuitive thinking and practical experience represented exactly the type of innovative problem-solving that his technology company needed to remain competitive in rapidly evolving markets. Louise Chun's modest repair shop had been transformed through a combination of the $50,000 reward and additional support from Marcus's business connections. Chun's Auto Repair now occupied a modern facility with state-of-the-art diagnostic equipment while maintaining the personal service philosophy that had characterized Luce's approach throughout his career. "The fancy equipment is helpful, but Sofia still finds problems that the computers miss," Luis observed while watching his daughter examine a problematic transmission that had stumped other shops. "She has a gift for seeing what's really happening, instead of what the diagnostic readouts say should be happening." The transformation of Chun's Auto Repair had attracted attention from automotive manufacturers who were beginning to recognize that Sofia's diagnostic methodology might offer insights into designing more effective troubleshooting approaches for increasingly complex vehicle systems. Representatives from several major automotive companies had visited the shop to observe Sofia's diagnostic techniques while documenting her visual inspection methods and logical thinking processes that had succeeded where conventional approaches failed consistently. "This young lady represents a paradigm shift in how we should approach complex system diagnostics," noted Dr. Jennifer Walsh from Ford Motor Company's Advanced Engineering Division. "Her success suggests that human intuition combined with systematic observation might be more effective than pure electronic analysis." The academic interest in Sofia's achievements had generated research projects at multiple universities where engineering professors were studying her diagnostic methodology while developing new curricula that emphasized intuitive problem-solving alongside traditional analytical approaches. Stanford University had established the Sofia Chen Research Initiative, focusing on understanding how untrained individuals could sometimes identify solutions that escaped highly educated specialists. The research had implications for fields ranging from medical diagnosis to software engineering, where complex system failures often transcended conventional troubleshooting methods. "We're discovering that formal education can sometimes create blind spots that prevent people from seeing obvious solutions," explained Dr. Robert Stevens, who was leading the research initiative. "Sofia's success demonstrates that fresh perspectives, unencumbered by conventional assumptions, can reveal problems that expertise overlooks." Sofia's story had captured international attention through documentary films and news articles that explored the broader implications of her achievement for education problem-solving methodology and the relationship between formal training and innovative thinking. The documentary 8-Year-Old Genius, the Sofia Chen story, had premiered at film festivals worldwide, generating discussions about educational reform and the importance of nurturing diverse approaches to learning and problem-solving rather than emphasizing standardized testing and conventional academic achievement. "Sofia represents hope that genuine wisdom can emerge from unexpected places," observed educational researcher Dr. Maria Santos. During interviews about the documentary's impact, Her success challenges fundamental assumptions about who possesses valuable knowledge and how we should identify and develop human potential. Marcus Wellington had integrated Sofia's diagnostic philosophy into his technology company's culture, establishing innovation teams that explicitly sought unconventional approaches to software and hardware, challenges that had resisted traditional engineering solutions. Sofia taught us that the most sophisticated analysis can miss simple fundamental problems, Marcus explained during a presentation to venture capital investors about his company's new problem-solving methodology. We've restructured our development process to include fresh perspectives from people who aren't experts in our specific technical domains. The approach had yielded remarkable results with Wellington Tech, solving several long-standing software problems through insights provided by individuals from completely different professional backgrounds, including artists, musicians, and even children who approached technical challenges without preconceived notions about what solutions were possible. Sofia's influence on Marcus's business philosophy had extended to his investment decisions as he began funding startups, led by entrepreneurs who demonstrated unconventional thinking rather than simply impressive credentials or sophisticated business plans. Traditional venture capital focuses on people who look successful according to conventional metrics, Marcus noted while reviewing investment opportunities. But Sofia showed me that breakthrough innovations often come from individuals who think differently rather than those who think better within established paradigms. The Chen family's financial situation had stabilized dramatically through the combination of Marcus's support and the success of their transformed repair shop, but Luis remained committed to maintaining the values and work ethic that had shaped Sofia's character during their years of economic struggle. Money changes circumstances, but it shouldn't change who you are, Luis told Sofia during their evening conversations about her growing fame and the opportunities that continued to emerge from her automotive achievement. Remember that your gift is about helping people solve problems, not about becoming rich or famous. Sofia's understanding of her role and responsibilities had matured considerably since her automotive triumph, though she remained fundamentally the same curious, intelligent child who approached mechanical problems with logical thinking and genuine desire to understand how systems functioned. I want to help people figure out why things don't work when they should, Sofia explained during an interview with Automotive Weekly about her future plans. There are lots of problems that smart people can't solve because they're thinking too hard about complicated explanations. The automotive industry had begun incorporating Sofia's diagnostic principles into technician training programs, emphasizing visual inspection and logical reasoning alongside electronic diagnostic procedures that had previously dominated troubleshooting methodology. We're teaching our technicians to ask what looks different before they ask, "What does the computer say?" explained Elena Rodriguez from Rodriguez Exotic Motors, who had become an advocate for Sofia's approach after witnessing its effectiveness. Sophisticated diagnostic equipment is valuable, but it can't replace careful observation and logical thinking. Sofia's success had also inspired other young people to pursue mechanical and engineering interests, with several children contacting the foundation to describe their own problem-solving achievements and request support for developing their innovative thinking capabilities. The foundation had expanded to support dozens of young innovators whose unconventional approaches to various challenges demonstrated the type of fresh thinking that Sofia had exemplified through her automotive achievement. We're discovering that there are many children like Sofia whose natural problem-solving abilities aren't recognized by traditional educational systems, Dr. Kien reported during the Foundation's first annual conference. Our goal is identifying and nurturing these capabilities before formal education discourages unconventional thinking. Marcus's relationship with the Chen family had evolved beyond simple gratitude for Sofia's automotive repair into genuine friendship, based on shared values about helping others and approaching challenges with integrity and determination. Sofia And Louise have taught me that success should be measured by the positive impact you have on other people's lives rather than simply accumulating wealth or recognition. Marcus reflected during his speech at the Foundation's fundraising gala. Their example has changed how I think about business and life. The Lamborghini that had started this entire journey remained a symbol of the unexpected connections that could develop when people were willing to look beyond conventional assumptions about capability and wisdom. Sofia continued to visit Marcus regularly to examine his exotic car collection, while learning about advanced automotive technologies that might benefit from her unique diagnostic perspective. Every time Sofia looks at one of my cars, she finds something interesting that I've never noticed, Marcus observed while watching her examine his newest acquisition, a McLaren that had been performing flawlessly. Her ability to see what others miss continues to amaze everyone who works with her. The story of Sofia's achievement had become a case study in business schools and engineering programs worldwide, illustrating how breakthrough solutions could emerge from unexpected sources when organizations remained open to unconventional approaches and diverse perspectives. The Sofia Chen case demonstrates that innovation requires humility about the limits of expertise, combined with willingness to consider insights from any source. Noted Professor David Kim during lectures about organizational innovation. Her success shows that the most valuable solutions often come from the least expected places. As Sofia approached her 9th birthday, she continued to balance her growing responsibilities as an educational foundation spokesperson with normal childhood activities and her ongoing role as her father's assistant in their thriving repair shop. I still like fixing cars with Papa the best, Sofia admitted during a quiet moment between interviews and educational activities. Helping people get their cars working again makes me happy because I know how frustrated they feel when something important doesn't work. The profound simplicity of Sofia's motivation helped explain why her achievement had resonated so widely beyond the automotive community. Her success represented timeless values about helping others solve problems through careful thinking and genuine concern for their welfare. The Chen family story had become an inspiration for families struggling with economic challenges, while demonstrating that remarkable achievements could emerge from modest circumstances when children were encouraged to develop their natural curiosities and problem-solving abilities. Sofia proves that genius can bloom anywhere when it's nurtured with love and given opportunities to grow, Louise observed while reflecting on the extraordinary journey that had begun with his daughters. Simple observation about loose connections in a billionaire's Lamborghini. The legacy of Sofia's automotive triumph continued to expand through the Foundation's work, the research it had inspired, and the countless individuals who had been encouraged to approach their own challenges with fresh thinking and willingness to question conventional assumptions about what solutions were possible. 3 years later, on a sunny California morning, Sofia Chen stood before an audience of automotive engineers at the International Diagnostic Conference. Now 11 years old and recognized as the youngest consultant ever hired by multiple car manufacturers. Her presentation topic: why simple questions lead to complex solutions. When I was 8, I asked why a perfect car wouldn't start, Sofia began, her voice carrying the same clarity that had characterized her approach to Marcus Wellington's impossible puzzle. Today, the diagnostic methods we developed from that question have solved over 2,000 cases that traditional equipment couldn't fix. In the audience, Marcus Wellington smiled proudly while Louise Chen recorded his daughter's speech on his phone. The Chen family's repair shop had become a training center where automotive students learned Sofia's visual inspection techniques alongside conventional diagnostics. Remember, Sofia concluded, the most powerful diagnostic tool isn't a computer or a scanner, it's curiosity. When you ask what looks different, instead of what should the readout say, you'll find answers hiding in plain sight. The standing ovation that followed represented more than appreciation for her achievement. It celebrated the profound truth that wisdom Innovation and breakthrough solutions can emerge from the most unexpected minds when we're humble enough to listen. Marcus's Lamborghini still runs perfectly, now serving as a mobile classroom where Sofia teaches young mechanics that sometimes the smallest observations can unlock the biggest mysteries. What incredible discovery will surprise you next? From hidden talents to impossible solutions, our channel brings you the most inspiring, real-life stories that prove extraordinary things happen when ordinary people refuse to give up. If this story amazed you, imagine what's waiting in tomorrow's episode. You won't want to miss it. Hit that subscribe button and the notification bell, because the most mind-blowing stories are just beginning. Tell us in the comments, what impossible problem have you solved with simple thinking?